Yeah, we've got our path. We got so many loops penetrating here. Out of all the loops in this solenoid, right?
Right.
Okay. The integral of B dot ds is 4 pi k prime times your enclosed current. Okay?
Right.
Well, that's going to be 4 pi k prime times your enclosed current. P is the length of the path. Okay?
Right.
Now, for reasons that we don't have time to elucidate, but just basically the currents, the magnetic fields from all these loops cancel out along this part of the path. Okay? And you get no contribution along these lines here because the magnetic field's always perpendicular to those lines. Okay? So the integral around the path
So the integral is not the same.
Frenchman says, they must be French.
Okay.
The I on the left board is not the same because the N over L times P is your enclosed current on the left side, right? On the left board times your I, which is the current of the whole thing, correct?
the current through every bit of this wire is
Right.
I.
Right.
So if this thing is penetrated by this many
Uh,
loops,
right.
then that's a total current that passes through the interior of this path.
Right. Okay.
Okay? Okay. So the integral around the path of B dot ds is just the integral over the path interior to the loop. If B is constant, then the integral around the path of B dot ds is just B times the path length. Now, the one thing I haven't mentioned, that clearly the magnetic field is going to be perpendicular to the loops by everything we did over here. So I'm waving my hands over a lot of stuff. There are details that have to be, but I'm not going to ask you to rederive this. Whole purpose of this is just to show you that the multivariable calculus has something to do with life. Okay? Flat earthers. There's a flat earther who claims to have disproved gravity so that now it's possible for the Earth to be a big disk with Antarctica around the rim.
Really?
And it's a Pac-Man world, so you can't get off.
Really?
So when you think you've gotten to the end, you just bounce back. I don't know. I mean, the topology is interesting. The scientific arguments are interesting, they're just not scientific, at least as far as I can tell. So if you disprove gravity, I mean, in gravity, you can't have a disk the size of the Earth. It would collapse into a sphere.
Yeah.
You got to disprove gravity. It says the only forces are electromagnetic. Okay? There's some very sophisticated reasoning to justify the preconceived notion that the Earth is flat. Okay?
Brain is flat.
Some of it's ridiculous. You know, high school geometry would disprove much of it, but some of it's pretty sophisticated. Anyhow, flat Earth aside, I'm mentioning that because this is all electromagnetic, right? So, you know, this, if you discount gravity, these guys have a pretty sophisticated but
Do they
easily
think
refuted theory.
Do they think all the planets are flat?
No, the stars are little dots out there.
What about the
They
sun?
don't have any gravity.
Is the sun flat?
I don't know. The only reason I talk about this is that I'm friends with a guy who is fascinated by these arguments. He doesn't believe them, but he finds them fascinating. And just something came up on the internet yesterday that caught my attention about that whole thing I just mentioned. Because when he mentioned it to me, I said, well, it can't be a disk. It's going to collapse gravitationally. And I just happened to run into him yesterday. I said, oh yeah, the thing I said about gravitation, you got to discount it. There's no such thing. Okay, you got a good laugh out of that. Okay, anyhow, so what you end up with, and I've been digressing, but I didn't have enough time to run out of time, so I didn't. B times, well, this path integral is B times P, which equals this. Barely enough room.
Sure.
So it's 4 pi k prime times your number of loops per unit length multiplied by the current. Okay? Now, if your
It's like basically the only things that won't compensize electricity.
number of loops per unit length gets, well, never mind. For coil, you got a lot of loops in a very small length. That's what a coil would be. So you can consider what that would end up being. Okay? Now, I'm saying this with a grain of salt. It might be half that because of something I didn't prove. Okay? Because I didn't prove and didn't even argue why the current out here or the magnetic field out here cancels. Okay? Now, why the magnetic field's not contributing along here and here, these are all approximate assumptions, but they're very close to being accurate. And along here and here, the field is perpendicular to these things, so it's not contributing to the line integral. Right? Well, those are the kind of things you have to think about if you're doing more advanced electromagnetism. So that's what I'm going to close with. Get out of here. No. Stick around if you got questions, but I got to let you go. And really enjoyed having you guys. You're a great group.